This is problem 2b from section 2.5. We have an inequality here. Remember, the only safe way to solve a quadratic inequality is to first consider the equation x squared minus 5 equals 0. I wrote that correctly this time. Solve that equation and see what the x-intercepts are, then go from there. You could actually factor this, or you can make sure that you get both solutions if you subtract the negative 5 from both sides, which is the same thing as adding 5 to both sides. Then take the square root. Now remember, you're looking for the possibility of two solutions, and you get that when you square root both sides. So your two x-intercepts are plus or minus square root of 5. So a quick sketch of the x-axis. Negative square root of 5 would be there. Square root of 5 would be there. 0 would be there if you want to be really, really compulsively complete. And we want to know what of the numbers on the x-axis satisfy the original inequality. Well, when we say above, we mean greater than. The 0 function is the x-axis. So we want to know, where is this graph above the x-axis? Well, first off, let's look at the graph. It's a quadratic expression. A equals 1. That's a positive number. So that means we open up. So this graph looks like this. And I kind of missed the x-intercept there. There we go. We make the x-intercept big and sloppy enough, we hit it. So we want to be above. Well, here's a graph which is above, but our solution is not the y values. Our solution is not this piece of graph. Our solution is the x values that make that happen. In other words, from here vertically down, we want that x and that x and that x all the way down. We do not want to include the big dots there because we want to be strictly above, so we need to put a circle there. Anything here we're above, so these corresponding x's all the way down to positive infinity will make the graph be above the x-axis. Likewise, exclude that and go down to negative infinity. Those x's make the graph be above the x-axis. So that's a really sloppy paintbrush picture of our solution set, but it does the job for this problem. We simply need to write down the solutions now. If for some reason you need to have an inequality, then you would simply say x is less than negative square root of 5, or, that or is required there, x is greater than positive square root of 5. If you're writing as intervals, you'll have two intervals unioned together, negative infinity, negative square root of 5. Now we're excluding the endpoints. That's why there are circles here. So we exclude by putting a parenthesis. We translate the union for the or, and then we exclude square root of 5 here. Go up to positive infinity. We always exclude the infinities because infinity is actually not a number. So either one of these would be a way to write the solution to this problem. Now, the next problem is a little bit more messy as a quadratic. The first thing we would do, write it as an equation. And then go about solving for the x-intercepts of that equation, finding the zeros, set it equal to 0 and solve for x. There is no way to solve a quadratic if you have x squared on one side and x on the other. You really are better off getting everything onto one side. So I'm adding a 7 next to both sides. If I look at that and I say to myself, 12 is the product of what numbers? I I think 12 and 1, 2, 12 and 1, 2 and 6, 3 and 4, and I think, well, a positive 3 and a positive 4 would add together to make a 7. So, very quickly, with a little bit of putzing around perhaps, I arrive at the factorization x plus 3 times x plus 4. I could check that by foiling, and I should arrive back at the previous step. So, since I'm equal to 0, it's important that you be equal to 0 if you're solving by factoring. If you're not equal to 0, then what you would write next would be gibberish. But since we equal 0, since we are multiplying, we know that x plus 3 equals 0, or x plus 4 equals 0. So x equals a negative 3, x equals a negative 4. I look at this parabola, and here the leading coefficient is 1. Once again, a equals 1. That's positive, therefore we open up. So if I draw my graph, put in the two x-intercepts, there's negative 4, there's negative 3. Stick in a quick sketch of a parabola opening up. Then we want it to be less than. That means we want the part that's under the x-axis. So less than, that means under the x-axis. So here is a graph that's being under the x-axis. Our solution is the x's that make that happen. So these are the x's shaded on the x-axis. Now, since we're under the x-axis, we're not allowed to be on it. So I do not want the x-intercepts, so I'll put a circle there to exclude them. So right there is a graph of the solution, like we've done in all the examples so far. Then the solution can be written out in inequality form. Negative 4 is less than x is less than negative 3. Or it can be written in interval form. Negative 4 comma negative 3. So sometimes it asks you to graph the solution. Then you just have the interval shaded with the correct treatment of the endpoints on the number line. Or you can have an inequality or an interval notation.